Work holding is a fundamental issue in performing any machining process. Work holding includes any device used to grip and present a workpiece to a cutting tool on a machine tool. It includes clamps, vices, fixtures, chucks, and more. The decision on how to hold a part influences which surfaces or holes are designated as reference surfaces or datums, which surfaces can be machined in a setup, the accuracy of the machining process, the allowable cutting forces, and thus possibly the cutting feeds and speeds, and the tool path and possibly tool size and shape. Work-holding devices must also suit production demands. They should be easy to unload and load. They must permit access of cutting tools to the workpiece so that multiple operations may be performed in one clamping. The work-holding setup and teardown should be as simple and as fast as possible. And for economy, standard catalog items must be used where possible. A machined part has certain planes, lines, and/or holes from which other points are measured. These reference points or planes are called datums. To correctly machine a part, it must be held in a setup that guarantees a definite location or position and orientation in space with respect to the part's datum points or surfaces. This must be repeatable part after part. Secondly, the work-holding device must hold the part securely in position while cutting forces, vibrations, centrifugal force, and gravity act to dislodge it. In theory, the location and clamping of workpieces are considered separate issues, but in work-holding practice, locating and clamping are integrated as part of the same process. The holding action ensures the workpiece is stable for machining once located. If not restrained adequately, the workpiece will move and become scrap. Conversely, the clamping force must not be inappropriately excessive, so as to distort, gouge, or break the workpiece. The 3-2-1 locational method is suited for rectangular parts located by their outer edges. With this method, 6 points of contact, or locators, on the faces of an object cancel 9 of the 12 degrees of freedom. These 6 contact points include 3 primary locators, 2 secondary locators, and a single tertiary locator. For accuracy and productivity, as many operations as possible should be completed in a single clamping. Reclamping or rechucking have 2 negative impacts. First, when the workpiece is moved, the location of the workpiece in relation to the machine tool is lost. That compromises the accuracy of the part. Secondly, setup time doesn't add value to the workpiece, and machining time is wasted at each unclamp-clamp cycle. Although a single clamping is ideal, 2 or more clampings or chuckings may be required when datum surfaces must be machined first, or a through hole has steps on both sides, or a part has blind holes on opposite sides.